All right, welcome to this video. We're going to get started with number 1. It says if the diameter of a soccer ball is 8 inches, how much air, it's kind of a key word for volume, in inches is inside the soccer ball? And then they say round to the nearest number. So like a lot of volume problems, the very first thing we have to do is like identify which of the 5 solids that we've studied. Like, is this a prism, a pyramid, a cylinder, a cone, or a sphere? And I don't know, spheres are one of the easiest ones to recognize, and probably the very best thing you could do is write down the sphere formula. I'll remind you that you will have the formulas. You just need to know which one to use, and so volume is equal to 4 pi radius, and here's maybe the interesting thing about a volume formula for a sphere, is we take the radius to the 3rd power, and then we divide it all by 3. And I'm sure you have noticed in your classes that really the only input we have to do is the size of the radius. Now, I don't know if you caught this, but we've got a little problem here. The 8 inches is not the radius, it's the diameter. And can I tell you, it's really easy to not notice that? Sometimes the geometry teacher just gets into a habit of thinking it's the radius, but like if you see diameter, I would highlight it with my pencil or something like that. So let's see, what is the diameter? The diameter is all the way across, and it's 8 inches. So how far would just the radius be? Can we all see that those would be 4? So the radius is 4 inches. All right, so let's rewrite this. 4 times pi times the radius cubed all over 3. And who are we filling in for our radius? 4. All right, so now all I have to do is do what the formula tells me. That's why it's so important to write the formula and then just fill it out. It will tell you what to do. So how about 4 to the 3rd power? That is 4 times 4 times 4. And if we check that on our calculator, okay, so I've brought up my calculator, and I'm going to do, I could do 4 times 4 times 4, but there's this nice to the 3rd power. All right, and I'm going to get that. So that's 64. I still need to multiply by 4, so times 4 equals, and I need to multiply by pi, so I'm going to take that answer and multiply by pi. And lastly, I need to divide that answer by 3. And it all comes out to be 268.08, and I think they want to the nearest, how much in inches, round to the nearest whole number. So the nearest whole number is this 8. We're either going to leave that in 8 or we're going to move it to a 9. Those are the only 2 choices. Leave it in 8 or move it to a 9. And we look at the number next to it to make our decision. 0 through 4 makes us leave it. So the answer to this one is 268. Volume equals 268. And what are we talking about? Cubic inches. Inches cubed of air. And there's our answer. All right, here's number 2. They give us a cylinder. They kind of did something nice and named them, and a pyramid over here. And basically, we need to decide if the volume of the cylinder and the pyramid are the same, or if one's more and one's less. So would you mind if we divided this into like 2 problems? Over here, maybe I'll do the cylinder, and over here I will do the pyramid. Okay, so how about the volume formula for a cylinder? That would be volume equals pi r squared, that's the area of the base, times height. All right, so let's see if we can fill those in. Pi times the radius squared times the height. So my radius is 1, and my height is 9. And 1 squared would just be 1, and 1 times 9 would be 9, and you just got to make sure you don't lose track of your pi. So 9 inches cubed. Now, we're going to compare it to something that doesn't have pi. You don't really want to be comparing something with pi with something that doesn't have pi. So let's grab our calculator for a second and work out what 9 pi really comes out to be. So here's my calculator, and I'm just going to type in 9 and pi and hit equals. And I'm going to round it off to the 10th. So 28.2, should I leave it at 2 or should I move it up to a 3? I look at the 7, it tells me to move it up. 28.3. So volume equals 28.3 cubic inches. And I'm pretty much done with that part. Now let's do the pyramid. So how do you find the volume of a pyramid? That is, volume is equal to the area of the base times the regular height, all divided by 3, right? Do you remember as the pyramid goes up, it gets narrower at the top and we lose volume, and that kind of where that dividing by 3 comes from. It takes away some of our volume. Okay, so what's the trickiest part of this is right here. They are not going to tell you how to do the area of the base. You have to figure that out for yourself. So do you notice what shape this base over here is? Is it a triangle? Is it a rectangle? Is it a square? Does everyone notice that this is a rectangle? So I have to know to do the area of a rectangle. And what is the formula for the area of the rectangle? This is not going to be provided to you. You just need to know that it's length times width. So who are we multiplying together? The 4 and the 2. 4 times 2 comes out to be 8 inches squared. So let's go back to this problem. Area of the base, which we just worked out, times our height, all divided by 3. Our area of our base was 8, and our height is 6. All right, 8 times 6. I actually am going to divide first. 3 goes into 6 twice. If this part bothers you, just multiply and then divide, but I'm going to divide first, and that means my volume is going to come out to be 8 times 2. That comes out to be 16 inches cubed. And let's see, can we compare our two volumes now? That's the volume of the cylinder, and this is the volume of the pyramid, and it's pretty close that the cylinder almost has twice as much. So it says the volume of the cylinder is, we'll write greater than. Okay, all right, that was number 2. All right, number 3 says the ice cream waffle cone, ooh, that looks good, below can be purchased at Dairy Queen. The cone has a radius of 3 centimeters and a height of 15 centimeters. Find the amount of ice cream, that's a tricky way to tell us to work out volume, that will fill one cone, and here they go. They don't want the exact answer with pi in it. They want the approximated answer. So we're going to need to use our calculator to work that out, but very clearly it is a cone. So the volume formula for a cone, this is where you should start on all your volume problems. Pi r squared times height, but because it gets smaller and smaller as you go up the height or down the height, we have to divide by 3. Okay, let's see if we can fill in our radius and our height. Volume equals pi, which is really just like the number 3, right? Times the radius squared times the height, all divided by 3. And let's fill in. Our radius is 3, and our height is 15. And now we just have to do what the formula tells us. Can I give you a little bit of a warning? Some people might see these 2 3s right here, and they might say, oh, it's really nice to divide first. I'm going to divide first. Do you see, because there's an exponent on it, you cannot divide before you do that exponent, so you shouldn't do that. I guess I'll point out, though, do you notice the 15 doesn't have an exponent, and it is divisible by 3? So once again, if this part bothers you, you could just multiply it all out and then divide by 3 at the end, but I'm going to divide by my 3 first. 3 goes into 15 5 times. Now I'm going to do my 3 squared. 3 squared comes out to be not 3 times 2, but what? 3 times 3, right? 3 2 times multiplied, so that comes out to be 9. And now I have to multiply the pi and the 9 and the 5, right? Everything else has been worked out. So that looks to me like it's going to come out to be 45 pi centimeters cubed. And the last thing I will do is approximate that with my calculator. So I'm just going to type 45 pi, and I'm going to round off at the 10th is what it said. So that means we're going to round the 3, and that means the 3 is either going to stay or go up. And what would the 7 make the 3 do? Stay or go up? It would make it go up. So this is 141.4. That would be the approximated volume, 141.4 centimeters cubed. All right, number 4 asks us to write the equation of the line passing through the point -4, 2, and it needs to be parallel to that other equation right there. So just in case you're not sure what this problem is even talking about, there is some point -4 up 2. I'm not even going to really graph it. I'm just going to put it about where it would be. And there's some line, y equals 3x plus 4. So 1, 2, 3, 4, and like up 3 over 1. So we have some line that looks like this. And what we want to do is draw or figure out the equation for another line that goes through that point and ends up being what? Parallel, right? So do you remember what they have? What must make them parallel? The pink line and the blue line, what makes them parallel? They have the same, what do they have? The same slope. Okay, so we want to write an equation for the blue line, and what we're going to need to use, do you notice that this is just a regular old point? It's not a y-intercept, right? Do you notice that point? This point right here is not on the y-axis. So we can't use the slope-intercept because we don't have it. We have to use the point slope. So here I go, point slope. And you'll need to do this on the test, right? So what's my point? It's negative 4, 2. And what's my slope? Well, to make it match this one, it's got to be 3. And what's the little formula I'm going to use for point slope? Y minus y1 is equal to m times x minus x1. And all I really have to do is fill in my y1 and my x1 and my slope. And do you see I have 3 numbers? Last thing I'll remind us is these minus signs kind of matter. Because the formula asks you to do minus x, whatever your x and y are, you have to do the opposite. Are you ready? So y, well, who's the opposite of my y value? Well, it's 2, so what am I going to write? Negative 2 is equal to, all right, here's how we make it parallel. We use the same slope. By the way, do you remember perpendicular lines? They don't have the same slope. They cross and make a right angle. What if they had said perpendicular here? Maybe on the test it will say perpendicular. You would do opposite reciprocal. So the perpendicular slope would be, what happens if you flip 3 over 1 over and do a reciprocal and change the sign? It would come out to be negative 1/3. But anyway, they didn't say perpendicular, they said parallel, and that's why we're using the same slope. And x, and who is my x value? It's negative 4, so I'll write in positive 4. All right, we are almost there. We already have our equation. That's what they wanted. They wanted the equation. It's just not in slope-intercept form. So let's take it out of point slope and put it in y equals mx plus b. So the y minus 2 will wait while I distribute. 3 times x is 3x, and 3 times 4 is positive 12. And finally, to get rid of that minus 2, I will add it. Those add up to 0 and disappear. So what do we have over here? Y equals 3x plus 14, and that's the equation for that blue line. It passes through this point, but it's parallel to the pink line. All right, here's number 5. It says find the length of segment GH with endpoints G and H. And just in case you don't realize what this is talking about, so there are endpoints, let's see, -1, -1 would kind of be down here, and -4, -7 would be right here. And we have some segment that connects them. And the question is, how long is this, right? That's what they're asking for, is the length. So you would either use something called what I call the length formula, right, because it works out length, or you would use, maybe your teacher called it the distance formula. But that length of segment GH is equal to, we do a big square root, and what we're going to do is take the x values, and what do we do with the x's? We subtract them. And what do we do with the y values? We subtract them. And then we square the results, and in the middle, plus. And to get this answer, you just kind of need to have that formula memorized. There's kind of a pattern to it, and if you kind of notice that pattern, it will be easier to remember. So here I go, GH, and if you're in my class, you know that I like to set up the whole formula and then put the numbers in last. So who are the x's? Who are the x's? That would be -1 and -4, -1 and -4. If you fill out the formula first, it makes it easy to like put all the minus signs that are supposed to be there. Okay, and how about the y values? That would be -1 and -7, -1 and -7. It really doesn't matter where you put the -7 and the -1. Either side is good, But do you notice we have this formula all filled out, and we just need to follow the math? So what happens with minus minus? It turns into plus plus. So negative 1 plus 4, that would be 3 squared. And again, we have a minus minus, so I'm going to turn it into plus plus. Negative 1 plus 7 would come out to be 6 squared, and we have a plus in the middle. So what does this give us? 3 times itself, that's 9. And 6 times itself, that is 36. And that means it all adds up to square root 45. And that would be how long this is, right? If it was square root 49, it would be 7. So this is just a little bit less than 7, maybe like 6.8, something like that. But all we would do is write square root 45. Number 6 gives us a segment with endpoints, and they want to know the, slope. So what do they mean by slope? Well, slope is kind of like the angle of our line, right? So like the bigger the slope, the steeper it is. And if you have a perfectly flat line, it has a slope of 0. And what about if your line is going downhill? It would have negative slope, right? So they want us to work out what's the slope of this. And hopefully you remember that slope, we like to use the variable m, is really just a comparison of the rise between 2 points, like how far from 4 to 8, versus the run, right? So how do you get the rise? How do you get the rise? Well, rise has to do with x values or y values. It has to do with y values. In fact, it's y minus y, and the run is x minus x. The only other thing you have to remember is that you should subtract in the same order. So you know me, I like to fill out my formula first and then drop the numbers in. So y's on top, I'm going to go with 4, take away 8. Okay, those are my y values. Now I'm going to do my x values. And do you notice I started with 4? So I should start with negative 6, take away negative 3. And once we work this out, we'll know the slope of this segment. So 4 take away 8, be careful, that comes out to be negative 4. And negative 6 minus negative 3 minus minus turns into plus plus. So what would negative 6 plus 3 come out to be? That would be negative 3. And should I leave a negative divided by a negative? Heck no. What is a negative divided by a negative? It's positive. Make sure that you change it to a positive if you're dividing two negatives. And that would be the slope. And after all, isn't this thing going uphill? Wouldn't we expect it to have a positive slope? And it does. Number 7, a cylinder has a height of 12 centimeters and a volume of 300 pi. It should be centimeters cubed. Find the radius of the cylinder. All right, so do you notice on most of these problems they're asking us to calculate the volume? But on this one they're not. They give us the volume. In my geometry classes, we talked about this as like solving backwards. All right, so how do you do one like this? Well, the very first thing we should do is figure out the right formula for this problem. And they are talking about the volume of a cylinder. So on the test, you will have a formula paper. You would use the cylinder formula for volume, which says volume equals pi times the radius squared times the height. All right, what we need to do next is just dump in all the details that fit into this formula. So a height of 12 centimeters, won't that height go right there? And a volume of 300 pi, well, it's the volume, so won't it go right there? So what will this start looking like? 300 pi is equal to, now make sure you make, right, like that pi matters. Make sure you don't just write 300. Equals pi times the radius squared times 12. Okay, so maybe I'll rewrite this. 300 pi equals, and what is 12 times? Wouldn't we write like 12 pi r squared? And the whole rest of this problem is about trying to get this r by itself. So do you notice the 12 pi is multiplying times it? What would cancel multiplying by 12 pi? Dividing by 12 pi. And over here, you know algebra, you have to do exactly the same thing. So what, 12 divided by 12, that will come out to be 1, and it cancels. Pi divided by pi goes one time, that cancels. So do you notice by dividing by 12 pi, we just got the r squared by itself? All right, and how about on this side? Pi divided into pi goes once, And now we have 300 divided by 12, and we should grab our calculator. All right, and we're going to do 300 divided by 12 comes out to be 25. So we got 25 is equal to r squared. And we don't want r squared, we want just r. So what would cancel the squaring? Square root. Take the square root of both sides, and good news for us, 25 is a perfect square. What times itself gives you 25? 5. So, and our units were what, centimeters? So the radius of this cylinder is 5 centimeters. And the big secret is to use the right formula for whatever they're talking about. All right, number 8 gives us two separate problems. They want us to find the volume of both of them, and they even go so far as to tell us that there are both prisms. So I'm going to use volume equals area of the base times height on both of them. Maybe I'll put that formula down. Those formulas help you figure out what you're doing. Okay, so a quick reminder. The most important thing about a prism is finding its base, and that doesn't mean the part at the bottom, right? What is the base in a prism? It is the base has to have a matching copy directly across from it. So let's start with the bottom. Would this bottom piece right here, this rectangle going all the way around, does it exactly match the top? Do those exactly match? Check. So I'm going to use this bottom piece as my base, but it's not because it's at the bottom. It's because it has this matching copy on the other side. So how would I work out the area for this shape? Well, what is it? It's a rectangle, and its formula would be length times width to get the area. So what would I multiply together? 6 times 8, and that all comes out to be 48 yards squared, and I got my area. So area of the base times height. The area of the base is 48. And what's the height? The height is actually the distance between your two bases. It's not really how tall it is. It's how far apart the bases are. So if these are the two bases, what's the height or the distance between them? It is this 15 right here. So I'm going to fill that in. And now it's time to grab our calculator. 48 times 15 equals 720. So 720 yards cubed. Okay, we've got our this green prism done. Now let's do the volume of this one. All right, so could I use the bottom of this as the base? Does it have an exact copy that's straight up from it? No, that can't be the base. All right, do you see the bases where there's two exact copies? Do you notice this triangle right here exactly matches this triangle right here? Those are the bases, even though they're not at the bottom. It's more of this exact copy kind of thing. In fact, let's talk about the height while we're at it. What's the height? It's not how tall this thing is, it's how far apart the bases are. So this 9 right here is actually the height. Okay, let's work on the area of the base. It's the triangles. What's the formula for the area of a triangle? It is base times height divided by 2. You kind of need to know that area formula. So in this case, base times height divided by 2, that would be 5 and 12. 5 times 12. Mr. Ferkin wants to divide that 12 first. 12 divided by 2 comes out to be 6. And 5 times 6 is 30 meters squared. All right, we got the area of our base. We can multiply that by the height or distance between those two bases, and we will have our volume. So 30 goes here. And how far apart are these matching bases? The height is 9, and that all comes out to be 270 meters squared. And those are our two answers. All right, number 9 asks us to correctly label the given information on both of the diagrams below. So all we're doing is labeling. So do you see that? What does this say? That says segment DC. Do you see segment DC right here? And segment AB are, what's that symbol? Parallel. So do you remember how we mark parallel? Do we use tick marks? No, we don't use tick marks. What do we use to mark segments or lines parallel? We use matching number of arrows. So I'm going to mark it like that. People confuse tick marks and those arrows all the time. That'll probably be part of the answer to show that you're not confused by that, so that's how you would mark it. Okay, then it says segment JG right here bisects angle what? HJK. What do you know about J? J must be the vertex of the angle. So HJK is this whole angle right here. And if it's getting bisected, wouldn't this angle and this angle be exactly the same? And how would we mark them the same? We'd put a matching number of loops on it. So that is how you would mark up, right? This is just like labeling or marking. That's how you would mark up this figure using this geometry information. This problem is about marking. And once again, what do you have to watch out for? Don't treat arrows and tick marks like they mean the same thing. They don't. All right, number 10 tells us this guy's at the store to buy some ice cream, and he has two choices that cost the same. And he can buy 2 cones in option 1, or he can buy 1 cylinder in option 2. And we need to, let's see over here, it says find the total volume. What do they mean by total? Do you realize that we've got 2 of them that are the same volume? So I should calculate 1 of them and then double it. And then on volume 2, there's just the 1. So when I get the volume of just this one, that will be the amount of ice cream. So let's go with option 1. Do you realize these are both cones? So the volume formula we're going to use is pi r squared times the regular height, all divided by 3. But then don't forget, there's 2 of these. So at the end, we're going to double it. All right, and so let's see if we can figure this out. Pi times the radius squared times the regular height, all divided by 3. And do you notice something about this 4 centimeters? Is that the radius? It's not. It's the diameter. Be careful of that. So if that's 4, wouldn't both of those be 2? So 2 squared, and then the height is 12. I'm going to go ahead and divide that. 3 goes into 12 4 times. 2 squared is 4, so that just came out to be 4 times 4, 16 pi centimeters cubed, but there's 2 of them, right? 16 pi centimeters cubed for just 1 cone, but there's 2. So this comes out, what is 16 times 2? 32 pi centimeters cubed. And I've got the volume of option 1, the total volume with both cones. Okay, time for option 2. This was option 1. Here comes option 2. What solid is this? That's a cylinder. Pi times the radius squared times the height. We don't divide by 3 because we get the full circle all the way up. So volume equals pi times the radius squared times the height. What should I fill in for the radius? Oh, there it is again. Do you notice they gave us a diameter? Watch out for that. Don't put in 4. If it's 4, then half is 2, right? So that would be 2 squared, and my height is 8. 2 squared, that's 4. 4 times 8 is 32 pi centimeters cubed. All right, and what do you notice? Which option will give him the largest volume? Either, right? You get the same. So we didn't have one be more than the other this time. Number 11 it's our first problem on the practice test that makes us practice some of the algebra we went over in this unit. So they want us to solve this equation, and what we're going to have to do is use our factoring skills. So that will be the first job. Do you remember what factoring means? It means to make multiplication. Okay, so I'm going to turn this into a multiplication problem in just a second. And after it's written like this, where 2 things are being multiplied and you get 0, because it does equal 0, then we're going to use this thing called the zero product property. So this is like a 2-part problem. This part's kind of pretty straightforward. This might take some thinking, especially because, do you notice that this has a leading coefficient? All right, we're going to do some guessing and checking. So what could I multiply together to get 2x squared? Wouldn't that just be 2x times x? And isn't that the only way that could happen? So I'm going to fill that in, 2x times x. All right, what we put over here has to multiply to be 15. So what are some ways you can get 15? I can only think of 2 ways. And if you're feeling stuck on this, you should really take the time to just write out the numbers that multiply to be your last number. So 15 times 1 or 3 times 5. Okay, and I'm going to plug them in. If it works out to be right, I found it. And if it doesn't work out to be right, I should either swap them around or use a different number. So I'm going to put 3 here, plus 3, and plus 5 here. And let's see if this gets us what we want. So what would 3 times x be? It would be 3x. And 2x times 5 would be 10x. And does that add up to 11x? It doesn't. So I just guessed, I checked it, it came out wrong, so let's try again. Okay, so this is still going to be 2x and this is going to be x, but I'm going to switch spots. Let's put 5 here and 3 here. If this doesn't work, I will start using 15 and 1, but we're just going to guess and check. So let's see, what does this make? This would be 5x, and 2x times 3 would be 6x, and those do add up to an 11x. We found it, we found it. All right, so these are the factors for this trinomial, and now I'm going to use my zero product property. And what does the zero product property say? It says if these two things multiply and you get 0, either 2x plus 5 has to be the part that's 0, or x plus 3 has to be the part that's 0. Okay, and this one's a pretty basic equation. I'm going to use the little shortcut that says if you have a simple equation like this, you can just take the opposite of the plus 3. So that's going to be negative 3. But over here, we have a little bit more to get the x by itself, so I'll subtract 5. Now 2x equals, what is 0 and negative 5? That adds up to negative 5, and if I divide both sides by 2, x will equal, and that doesn't divide evenly, so I will just leave it. There are my two answers. Either the x is negative 5 over 2 or it's negative 3. First you factor and then you use zero product property. All right, number 12 is a lot like number 11. They gave us a quadratic equation, or one with x squared, and it equals 0. So we are going to factor again, and then we're going to use the zero product property. And good news, there's no number right there as a leading coefficient. So factoring this is way simpler. All we have to do is look for numbers that multiply to negative 28. So what would those be? 28 times 1, negative 1, or negative 28 times positive 1, or 14 times negative 2, or negative 14 times positive 2, or negative 4 times 7, or positive 4 times negative 7. Those are all the things that multiply to negative 28. So do any of these also add up to negative 3? And do you see that negative 7 and positive 4, those are the ones? So my factors are x plus 4 times x minus 7. And if I wanted to just double check, does x times x make x squared? Correct. Positive 4 times negative 7 makes negative 28. This would be 4x, and this would be negative 7x. And yeah, they make negative 3x. That looks good. All right, time for some zero product property. So either x plus 4 is equal to 0, or x minus 7 is equal to 0. And I'm going to do my little shortcut and just do the opposite. So this would be negative 4 or x equals positive 7. And those are the solutions for. Number 13 asks us to find the volume of this pyramid. And maybe the very first thing we should notice is this 18 inches right here. Do you notice that that is a slant height? It is not the kind of height we would want for volume. Maybe I'm getting a little ahead of myself. Probably the very best place to start is by writing down the formula we should use. So what's the volume formula for a pyramid? It is that we should find the area of the base, multiply by not its slant height, but by its regular height. But because it gets narrower and narrower and narrower as you go to the vertex, we have to get rid of some of that volume, and we have to divide by 3. All right, so I don't know. Maybe we will start with the kind of the easy part. The base is this square. Maybe not the easy part, but like a very central part. It's this square down here, and we need to find its area. So the area formula for a square is side length squared. So in this case, we're going to square 12, and that will give us 144 square inches of area, and we got the area of our base, just like that. The big part of this problem is going to be finding the height. So would you join me? They didn't even draw it, so let's draw our regular height coming straight down to the center of our base. And what we're going to do as well is draw from the bottom of the slant height over to the regular height. And I hope we can all see that we have not just any triangle, but we have a right triangle. And because we have a right triangle, we can use the Pythagorean theorem that says what? Leg squared plus leg squared is equal to the hypotenuse squared. But maybe you'll notice we kind of have a big problem. We know this hypotenuse is 18 inches. We don't know this leg, which is the height that we want. And we don't know this one either. So we can't really work this out if we have two variables. And what we need to notice is if this whole distance right here is 12 inches, this will be halfway, and that will make it 6 inches. And now we have two sides, we can figure out the one that we're missing. So I'm going to call it my regular height because that is what I'm looking for. So what? H squared plus 12 squared is equal to, I almost screwed it up, didn't I? Not 12 squared, that's the whole thing. That is only 6 inches. 6 squared is equal to 18 squared. All right, so you can't do anything with h squared. I'm just going to leave it h squared. But 6 times itself comes out to be 36, and 18 times itself comes out to be 324. 324. All right, let's get that h by itself. I'm going to cancel that 36 by subtracting it. That means h squared is going to equal, let's say I can't take 6 from 4, so I'm going to borrow from the 2. That'll go to 1. 14 minus 6 would be 8. I can't take 3 from 1, so I'm going to borrow from that one too. 11 minus 3 would also be 8, and there's a 2 right there. And I don't want h squared, I just want h. So I'm going to take the square root of both sides. And square root 288 happens to not be a perfect square. You could check it on your calculator. So we are going to leave it square root 288. And that is how tall this thing is. I think 289 would be 17, so this is like 16.9, which kind of makes sense with this 18 right here. So here we go. Volume equals the area of my base times my regular height, which I just worked out. Maybe I'll write it in right there, square root 288. And what was the area of my base? 144, and I'll divide it all by 3. If you use your calculator, you'll see that 3 goes into 144 48 times, and that means our final volume for this would be 48 square root 288 inches cubed. And maybe the biggest part of this problem is figuring out the regular height because they didn't give it to us. Number 14, the volume of a triangular prism is 2,850 units cubed, and they want us to find how tall this is. So this is one of those problems where we have to work backwards. Instead of working out the volume, we already know it. What we're going to have to work out is how long this segment is right here. Good news, we can just use our normal formula. They did us a big favor and told us it was a prism, so that volume formula is find the area of the base and then simply multiply by the height. And the biggest thing to realize on a prism is who is the base? So let me ask you this. Well, isn't the base just always the bottom? Well, it could be the bottom, but to be the base of a prism, whatever's the base should have a matching copy straight above it. Do you notice the bottom does not have a matching copy? In other words, the base of this prism is this triangle right here, right? It exactly matches this triangle right here. Those are the bases of my prism. So here we go. Let's start dropping things in. If they gave me the volume, I'm going to put it in. 2,850 is equal to, how would I do the area of one of these triangles? Well, the area is equal to base times height divided by 2. In this case, I'm going to be multiplying 15 times x, but I still have to divide by 2. That all comes out to 15x over 2. So I got 15x over 2. And now I need to multiply by the height. Now be careful. Some of us might say, well, it must be x tall because that's how tall it is. But That's not how prisms work. The height is actually how far apart our two matching bases are. And how far apart are they? Can you see that this 19 right here is how far apart the bases are? So that would be 19. All right, so let's see what we got. We got 2,850 is equal to, and I'm going to pull up my calculator and work out 15 times 19. It comes out to be 285. So I have 285x all over 2. I think I'm going to get rid of that dividing by 2. What would cancel a dividing by 2? A multiplying by 2. So we're going to multiply both sides by 2. Those will cancel. So I've got 285x. And over here, let's see, this comes out to be 285.50 times 2 comes out to be 5,700. So 5,700. And last but not least, we'll get rid of that multiplying by dividing. And x equals, back to the calculator, 5,700 divided by 285 comes out to be exactly 20. 20 units. Okay, so good old formulas, plug it all in, and then it's just some algebra. Number 15. A cylindrical candle is placed inside of a shipping box. The length of the box and the height of the candle is 20 inches, and then they give us all kinds of measurements, and they want to know, three things. What's the volume of the rectangular prism? Okay, we know about that. What is the volume of the cylindrical candle that's inside the box? We can do that. And then this is the key part. They want the airspace in the container. In other words, when you put the candle in the box, it takes up some of the space, right? But it doesn't take all of it. The remaining space in the box on the outside of the candle, but inside of the box, is like filled up with air. So here is basically the idea for this last problem. We are going to get the amount of air, the volume, by taking the whole box and taking away the candle. And what's not being filled up by the candle is the air. So if we take that candle away, we will get the air. So that's how we'll do that last one. But let's get started with part A. So the volume of the rectangular prism, volume equals area of the base times height. Okay, so I think I'm going to use this 16 by 16 as my base, as the other side looks exactly like that. So the area is equal to side squared. That's 16 times itself. If you do that on your calculator, you'll see it comes out to be 256 inches squared. So there's the area of my base. And then I need to multiply by my height, and the distance between those two matching bases is 20. And if I multiply that out, the volume is going to equal 256 times 20, 5120. 5120 inches cubed. All right, we got part A done. Now it's time for part B. I'm going to switch to a different color. We're talking about the candle itself. It's a cylinder, so that's area of the base, which is a circle, times the height. We're not going to divide by 3 because you get that full circle all the way up and down that height. So pi times the radius squared times the height. Radius is 5, and the height is also 20. So that's going to be what? 25. 5 squared is 25, and 25 times 20 would come out to be, I think this comes out to be 500 pi inches cubed. And we're going to get an approximated volume. In just a second, we're going to be subtracting these two answers. You really can't subtract something like 256, which doesn't have pi, away from that's not the right thing. 5120 from something with pi. So let's approximate this. I'm going to round it off to the nearest tenth. So let's use our calculator for this part. 500 shift pi equals, and we're going to round it off at the tenth right there. Actually, I'm not going to round it off. I'm going to leave it on my calculator. If I were rounding it off to the tenth, I would round off the 7. It would either stay a 7 or move up to an 8, and the number right next to it is a 9, so it would move up to an 8. 1570.8. 1570.8 inches cubed. All right, so I got the volume of the candle, and now it's time for this air idea. And really all I have to do is take the volume of the whole box and then take away the candle, and what's left is the air that's in there. So I'm gonna finish this problem on my calculator. I'm gonna go purple. So the volume of the air is just 5120 minus this answer. So let me show you the best way to do this. Do you notice I still have, don't clear your calculator until you really need to, because who knows if you need the answer that you just got. So I'm going to take 5120 and subtract away, and check this out. If I press this answer button, it fill in my answer from the last problem I did. I can hit equals, and there it is, 3549.2. 3549.2 inches cubed, and this is the volume of the air. So we really just have to understand the concept that inside the box is the candle and the air. If you add them up, you'll get the whole box. If you subtract one of them, you'll get the other one, and that's what we did. All right, number 16 is one of these algebra review problems that we really studied, especially for our juniors who will be taking the SBAC test this year. There's a lot of algebra on that SBAC test, and you learned it, but it's been a while, so we're going over it. All right, so they want us to multiply, and the interesting thing about this problem is that there are two things to multiply. We need to distribute the 9x to those x and minus 1, and we need to distribute the plus 4. So one thing at a time, let's distribute the 9x times x would come out to be 9x squared, and 9x times negative 1 comes out to be negative 9x, and that guy is done. It is time for the positive 4. Positive 4 times x would be plus 4x, and positive 4 times negative 1 comes out to be negative 4. And like usual on a lot of these problems, we end up with a pair of like terms in the middle, and we're just going to combine them. So this comes out to be 9x squared and the minus 4. But what would negative 9x and 4x add up to? Negative 5x, and that is the product of these two factors. Factor times factor equaled our product. There's the answer to this multiplication problem. Here's number 17. They want us to take the binomial x minus 9 and multiply it times itself. Can we start with the most common wrong answer? In fact, this answer is sometimes more frequently given than the real answer. Students will say, oh, I'm just going to square both of those, and I'm going to get x squared plus 81. Well, if you do that, you just got it wrong, because that's not really what this is saying. You see the parentheses, you might want to distribute, but don't distribute. Who is the base on this exponent? Do you realize it's this whole thing? All of this is being taken to the second power. And what does it mean to take something to the second power? It means you multiply it times that thing itself however many times, in this case 2. So wouldn't this mean that x minus 9 is getting multiplied times itself twice? That's what this means, not that, right? You don't distribute. We're not multiplying, we are using a power. All right, so just like before, we've got to distribute the x, and then when we're done, we have to distribute the negative 9. Let's start with the x times x would be x squared. X times negative 9 would be negative 9x, and x, you are done. Now it's time for the negative 9 times x would be negative 9x, and negative 9 times negative 9 comes out to be positive 81, and there's our two like terms that are just waiting to be combined. So our final answer, x squared in the front and plus 81 on the back, and a negative 9x and another negative 9x would all add up to negative 18x. Okay, don't distribute the power. That's bad math. That's bad math. Number 18 asks us, instead of multiplying, to factor, which means to go backwards, and instead we're starting with the answer, and we're going to make the multiplication problem. All right, so let's start building a multiplication problem. And a little bit of bad news for us. This one has a leading coefficient. So can you think of some things that we could put here and here that would multiply to 3w squared? Well, wouldn't that be 3w times 1w? It's kind of the only way to get 3. But over here with negative 21, I can think of 4 ways to get negative 21. We could do negative 3 times 7, or positive 3 times negative 7, or negative 1 times 21, or positive 1 times negative 21. And what we need to do is just kind of put these in here and see if we can get everything to work out to be that -2. So I don't know. I'm going to put the -3 there and the +7 there. So this would give me -3w, and this would give me 21w, and those don't add up to -2w. So that wouldn't work, and it would even be positive. So I think I'm going to switch the 7 and the 3. So that didn't work. Let me put a little line through it. So 3w, I know that's going to be there, and this w here. And let's go with +7 and -3, and let's see what this makes. So this would be 7w, and this would be -9w, and I think I found it. This is the right one. Okay, 3w, it works out to be -2w, so those would be our factors. And if it didn't, we would just keep working. I would say the most common thing students mess up on is they just start doing this without doing this first. This is the secret. This is the secret. Okay, if you can write down all the ways real fast, or even, that will help you find them, right? That will help you find them. Those are the factors. Number 19 says, select one of the factors of x squared plus 3x minus 40. So this is kind of a weird problem. And the thing that they're doing is they've made it into a multiple choice problem, but they don't want to give you all the factors because you could just multiply it out and figure out which one works. So by only giving you one, they can have a good multiple choice question, but make you factor at the same time. All right, a little bit of good news. There's no leading coefficient. So really all we have to look for, these are going to be x, right, are things that multiply to -40 and add up to 3. So what are you talking about here? 4 times 10, 2 times 20, 8 times 5. I think I found it. 8 times 5 will make, and one of them has to be negative, right? And that means they're going to subtract to be 3, and I want them to be +3, so I think I want the +8 and the -5. Is that right? Do you notice how I did all this factoring and I haven't even looked at these? I think if you factor and then match, you're gonna get this right every time. So which one of those? X plus 8? No, there's an x plus 8 right there. X plus 8. That would be the letter choice that we'd pick, letter choice D. Okay, so do your factoring and then match it. If you're staring at these, you'll get distracted. Number 20, they want us to factor with a leading coefficient. So let's see. Let's start making our factors. The only way to get 5x squared is to use 5x times x. But I'm going to follow my own advice and write out all the ways to get 18. So that could be what? -6 times 3 or +6 times -3. We could do -9 times 2 or +9 times -2. And I think the last one, -18 times 1 or +18 times -1. One of those combinations will work, and we want to end up with -27. So let's see, -27. Let's put, do you realize I'm kind of working this out in my head? Maybe you have practiced enough at this to do it too. So let's put positive, let's just use our first one, +3 and -6, all right? Those will make 5x squared, they'll multiply to -18. What will we get in the middle? This would be -6x, and this would be +15x. Do those add up to -27x? No. So our first guess checked out not to be the one. So let's switch it around a little bit. I'm still going to have my 5x and my x, and let's put the -6 over here and the +3 over here. Still makes -18. All right, what would this be? 3x, and this would be -30x, and do those add up to -27x? Bingo, I think I found it. My two factors are 5x plus 3 and x minus 6. Okay, and you'll notice I did my little secret, which is writing out the possibilities and then trying to do the factoring. All right, here is our last question. Write an expression equivalent to x plus 6 squared plus x minus 5 using the fewest possible terms. This question is actually right off the SBAC test, and that's why it is on this. It's kind of why we did our algebra, to get our juniors this year or our sophomores next year, ready to do great on the SBAC test. Okay, so do you notice that really this is kind of like a take this to the second power, multiply it out kind of thing, and then when we are done, we're going to add this in and just try to combine some like terms. So let's take that x plus 6, and what does it mean to take it to the second power? It means x plus 6 getting multiplied times itself 2 times. There it is. All right, let's distribute the x, and then we will distribute the 6. So here I go. X times x is x squared. X times 6 come out to be 6x, and Mr. X, you are done. Let's distribute the 6 times x. Comes out to be 6x. 6 times 6 would be 36. If I combine my like terms, what do I end up with? X squared plus 12x plus 36. But now I'm going to add this in. So I'm going to add on plus x and minus 5. And all we're going to have to do is combine some like terms. So do you notice this thing with x would match up with this thing with x? Sorry about that. I was trying to find the pause button before I did that. Hope you weren't wearing headphones. You probably were. Oh, no. Anyway. All right, and also this plus 36 and this negative 5 go together. Do you notice nothing's an x squared? So maybe I'll just bring that down. The x squared stays, but how about the 12x and another x? That would make 13x. And how about positive 36 minus 5? That would come out to be positive 31. And that right there would be the answer to this problem, right? They make it sound a little crazy with like equivalent and fewest possible terms. But really, you're just doing the multiplying you can do and then adding up the like terms that you have. All right, good luck on your test. Hopefully watching this video. All right, number 22 asks us to factor this expression. We should maybe notice a couple things. It is an expression. In other words, there's no equal sign. We are not going to be solving for the x's in this problem, but we are going to factor it. And what does that even mean? It means to turn this into a multiplication problem. So the way we do this is we first look for our greatest common factor. In other words, is there a number we could multiply by and get both 12 and 9? In fact, we want the greatest number, the biggest number. So that biggest number is 3. Both of these can be multiplied and get 3. There is no larger number, like 12. You could multiply 6 by it to get 12, but 6 doesn't play nice with 9, so we're going to stay with 3. And then we should ask ourselves, how many x's do both of these terms have at least? And they at least both have 2. All right, once this right here is the GCF. That's the GCF. And what we're going to do is figure out what this GCF would be multiplied by to turn it back into this product right here. So here we go. What times 3 would give you 12? 4. And if you have x squared and you need x to the third power, does everyone notice you would just need one more x? All right, now 3 times what to get 9? Positive 3. And I already have x squared, and all I need to do is end up with x squared. So there it is. There is the factored version of this expression. We took this, which is basically a product, and we turned it into factor times factor. That's what factoring does. It makes a multiplication problem. All right, number 23 is a lot like the one that we just did, except there's a really big difference, and that is it's not just an expression. This is actually an equation, and we are going to solve it. So first off, we need to factor it, and we should notice that this is not a trinomial. And every time you don't have a trinomial, you should know you're going to try to factor it using a GCF. If it is a trinomial, then you will try to factor it into 2 binomials, right? There's like 2 styles of factoring, and when you don't have a trinomial, it is pretty much always GCF. Okay, also we should notice it's an equation. So after we are done factoring, we're then going to use this thing called the zero product property to solve. It basically says if you have 2 things and they get multiplied and you get 0, there's only one way that can happen. 0 is kind of an interesting number. Either the A would be 0 or the B would be 0. All right, let's see if we can do some factoring here. So Let's find our GCF. What is the biggest number that multiplies to 10 and 25? That would be 5. And this one has 2 x's and this one has 1, so they at least both have 1 x. There is my GCF. Let's figure out what the other factor is. What times 5 to get 10? 2. If I've got 1 x but I need 2 of them, I would need 1 more. And what times 5 to get negative 25? Negative 5, and I already have that 1x, so there it is. I've got this factored. If all we were doing is factoring, we'd be done, but this is an equation. So now that we have one thing times one thing equals 0, let's use our zero product property that says, to get 0, when you multiply, either the 5x is the one that's 0, or the 2x minus 5 is the one that's 0. All right, let's solve these little equations. We'll have found our 2 solutions. So if I divide both of these by 5, x will equal 0. And over here, to get the x by itself, I would add 5 to both sides. So now 2x is equal to 5. And if I divide away the 2, there it is. X is all by itself, and it equals 5 over 2. These are my 2 solutions. And we did some solving because this one was actually an equation. It's kind of important that you notice when you have an equation and when it's just factoring.